Well, good morning, fellow YouTubers. Oh, that was gentle, wasn't it? Today is Memorial Day, 2022, and I'm out in my shop because I'm not at work today, bored. So I have a Wavetek model 3001 signal generator. It goes, it's actually a military version, as you can see here. It's a SG -1170/U. It actually is modified to go from 0.001 to 520 megahertz. Has an internal high reference oscillator. It's got a few extra mods on it, and got a few of these cards here. I think that IMSA guy had a function generator that was built kind of like this right here. And I have, this was my main signal generator for a bunch of years. But it was old, long in the tooth, had a lot of problems. And I just decided to get me one of these guys, little HP 8657A signal generator. It goes from 0.1 to 1040 megahertz. This thing is really cool. Anyway, I'm kind of bored today. I've kind of run low on projects. One of my projects that I'm working on, and I didn't record anything, was this HP right here. This model 400D vacuum tube voltmeter. It's an AC voltmeter, and I don't remember what exactly the range is, but I mainly will use it for AC. But every time you turn this thing on, there would be something there on the meter reading right about 0.5 to 0.6 on the top scale, or 0.05 if you want to get really delicate about it. Anyway, it was something always there. And if I put my scope on the output right here, in other words, this output here will show you, you can connect it to an amplifier or to an oscilloscope or whatever, so you can see what you're actually feeding this thing. Anyway, when I put this on here, I was showing 120 hertz ripple. I forgot, like 0.12 volts or something like that, but definitely had a power supply issue on this thing. Anyway, I've took this thing back apart. I've had it open a couple of times, just messing around with it, and tested all the electrolytics in it, and every electrolytic in this thing was bad. There was actually one set, it's got two sets of 20 microfarad at 450 volt electrolytic cans in here, and there was one section that was completely open. The other one was open and super leaky, and then it had two sets of I think 20 microfarad single terminal capacitors, 20 microfarad at 450 volts. I'm sorry, I'm thinking of somebody else's. There were two 1500 microfarad 15 volt capacitors across the filament string. The filament string on these things are rectified and turned into DC to help cut down on noise. However, they were open too. And of course, I checked it on my handy dandy little Sencor SE103 resolver. This thing is the bomb. If you guys can find one of these, that's fantastic. I love this thing. It will check capacitors and inductors, as it says here. Anyway, let's get back to the subject at hand. This thing here has a lot of phase noise, or what I'm calling phase noise, in it, with several problems. It doesn't want to lock sometimes if you change frequency, so something's not quite right. The calibration of the deviation is not right. It levels, the level control becomes unleveled on AM varies. It's very touchy to being unleveled. Let's see, what else? Let's see. Oh, and it has a lot of something in the mod. When you're listening to it, you can hear it almost like it's ringing if you're listening to it on a receiver or something like that. So this thing's got a lot of problems. A lot of it, I think the unlevel has to do with probably dirty pots, because if you can turn the vernier control here, it will make this thing go on low. You could tell the control is dirty. It's been a long time since I've been inside this thing. There's all kinds of cans in here. There's PLL loops. That's PLL loops to PLL loops. This thing is PLL happy. So I've been in it, like I say, a bunch of years ago. I'm going to have to get caught up on it, but I'm going to plug it up, set it up, find the manual, and get myself used to it, and then I can bring you back. But it ought to be a very long, interesting project, and I'm not sure I want to tackle it or not, but it would be nice to get this thing working. This could be one of my long series. So we'll just call this episode 1. Episode 1, Wavetek model 3001. So let me get set up, get my spectrum analyzer out, and we'll get all this stuff hooked up, and we'll do a functionality test. I'll bring you back. Okay, I had to do a few things here to get ready. So I have the signal generator plugged into the variable isolated power supply, the AC, the Syncor PR57. Really neat. You can find one of those. They're relatively cheap on eBay, or used to be, until the people just figured out that they could sell this stuff for a lot more, because people were stupid enough to pay for it. Anyway, there's that. Plugged into that always, so that way I can monitor everything going on. Got a Teflon coax plugged into my baby right here. This is still a work in progress, but it works good enough for me. The variable ACE, the HP8568B spectrum analyzer, this one here, goes from 100 Hertz up to 1.5 gigahertz. Very nice. We will be using this. It sounds like the back end of a jet airplane, but anyway, we're going to turn the device on and let's see what it does. What will happen is, I believe the external will come on flashing, and what the external means is somewhere in here, somewhere in this thing, and I think there's a high stability oscillator in here somewhere that when this thing is modified to do that high stability oscillator, I don't remember where it's at because I haven't got the manual out yet, but we'll get the manual out and kind of figure out where these modules are, and we'll do that later. Anyway, let's turn it on. Let's see what happens. And before I turn it on here, I'm going to set this for, let's see, let's set it for -20. So here on the scale, -20. So at 0 on this scale, that should be -20 coming out of this port. So anyway, I've set it up for 100 megahertz. Alright, it's kind of mid-band. So I got this set up for 200 megahertz into port A. So this thing should be ready to go. So here we go. And no power, Captain. Let's turn the ON OFF switch on. Here we go. Round 2. Fire it up. Does come up. See the external flashing here. The heater's not warmed up yet in the high stability oscillator. We're in calibrate on the vernier. We'll turn this down. You see how when I turn this, see how the level does? That's got to be repaired. But anyway, I have it at -20 on the range switch, and this is at 0. So when this thing comes up and locks, if it locks, you should see -20 dB worth of 200 megahertz here. So as you can see, like I said, you see that control is in need of cleaning if I can get to it. I may have to take the stupid thing out, take it apart and clean it, but that's definitely one of the problems. So we're just waiting on the thing to, if it will lock. I'm not sure it'll lock or not. It's very flaky. That's one of the problems with this. So when it locks, I'll bring you back. Alright, well, we do have a signal now. And this is another project that I'm going to have to do. Is this thing, this spectrum analyzer needs an alignment. You see the slope right here is not quite right. That's an alignment issue. Anyway, we do have signal output right here. Oh, it locked. There's the external. So we locked at 200 megahertz. We should be putting minus 20 dB out. So let's come back over here. It seems to be on frequency. This thing was on frequency. I'm not going to measure that, but let's see what we got here. And we're about minus 19.3, so it's relatively accurate. Let's adjust. I'm going to adjust the vernier control right here. This is the one that's flaky. Let's see what happens. You see that as I turn it? Definitely needs. So that's minus 20 right there. And it's off not a whole lot. So it did lock. Which is amazing, actually. It actually fooled me. This thing hadn't worked this good in a while. Let's change frequencies. Change it to 100 megahertz, 200 megahertz, 300 megahertz, 400 megahertz, 500 megahertz, 520, 530, 540. Still locked. It's at 550, 560, 570, 580. Oh, it didn't like 580. We're at 570. Let's see what it's doing at 570 megahertz. Look at there. It will go up to 570. That's amazing. Let's go back down. Go to 70. Well, this thing, I know it's unstable. Let's do 270. Go over here. You see how that trace is? I'm gonna have to work on this too one day. I just see that right there, that little lump right there. This thing is not aligned properly. That's 100 kilohertz bandwidth, 30 kilohertz bandwidth, 10 kilohertz. See, that looks really good on the 3 kilohertz. We'll leave it at 3 kilohertz. It looks better there. It doesn't bother me so bad. So, that's where we're at. This thing is, you know how you go have aches and pains all your life, you know, or, you know, you wake up one morning, got aches and pains, and it lasts for 4 days, and you go to the doctor about it, and while you're sitting in the office, they go away. Kind of what we got here. Now, granted, this thing has not been plugged in. It's not hot at all. So, I don't know. Usually when you change frequencies, this thing would go nuts. It would definitely go out of lock. Make a liar. Oop, there we go. There's our old buddy. There we go. Well, that's as simple as this BCD switch. These things can get dirty too. Definitely went out of lock. There we go. So at 150 megahertz. No output. We have something not locked. So let's look on the top. And there's LEDs on some of these indicating the loss of lock. I see no LEDs. So that's what we're after. Now the power supplies on this thing This capacitor's there's a big old 10,000 microfarad 16 volt, that orange capacitor down there, that's in there. Got another one over here. These appear to be 1500 microfarad at 50 volts. This one here and this one here. Various other things in here. So it is not locked. Let's do my frequency span at 5 megahertz. Yeah, see nothing coming out of the device. So it's not quite right. I'm wondering if, I think what we need to do is, first off, let's go clean this. I'm going to clean this vernier control for the output level. I'm going to clean it if I can. And then we'll get this, I'll find the manual somewhere, and we'll just start really don't know where to start. I'm just thinking, what we'll do is we'll do a alignment. Let's do the alignment procedure. Usually alignment procedures, sometimes if you do an alignment procedure, you have to be careful. Let me finish what I was going to say first. I'm going to do an alignment procedure to find out what works and what doesn't, basically. The thing is, sometimes if you do that, you can make it worse depending on the problem. But on this one here, it's got so many phase lock loops in there and stuff like that, that we can go do the alignment, or I can do troubleshooting. However, there's no LEDs on here to tell me anything's out of lock. So I think I'm just going to do an alignment that will show me if something's working or not. And I think I'm just going to do that. And if I can't get something aligned, I'll fix whatever that problem is and move on from there. So anyway, let me find the manuals, and we'll start the alignment procedure on this thing right here. And also probably going to check the power supplies. I don't think it's a power supply issue, but who knows. So I'll bring you back. Okay, there you are. That might be a little better. All right. So I guess where we ought to start, calibration procedure. Remove the instrument top and bottom covers. Allow a 2-hour warm-up period. It's been 30 minutes. Anyway, we're going to look at the voltage power supply adjustment first. So we'll use my trusty old 8010 voltmeter. Get all these leads out of the way. So I've seen a lot of people's videos on YouTube and how they do stuff. It's still out of lock. First off, still out of lock. So let's see. So yes, I'm going to check voltages. I'm going to use my little digital meter, and plus 18 volt adjustment. Connect the digital voltmeter to the orange plus 18 volt line on pin 3 of module M30-1. So all that is right here. So let's find us a suitable ground. This appears to be a ground right there. I'm just going to use these little clip leads here if anybody has. So I got to find the M30-1 module. Let's see, so we're looking for an orange wire. I'm assuming, if I remember right, all the orange wires are the same thing. So let's just see what's on there. And here, let's just do it this way. It's a lot simpler. is at 18 volts. I've just connected to the orange wire. I believe all these orange wires are the same thing. So we're good there. Let's find the minus 18. Connect the digital voltmeter to the yellow minus 18 volts. So here's a yellow. Just find a convenient spot. It'll stay. Minus 18. So that's good. And now we'll go down to the plus 7.3 volt check. Connect the voltmeter to the green plus 7.3 volt line, which this is probably this one. Whoop. Try again. Ain't a little fat. It's good to here get one that ain't quite so fat. There we go. 7.25. That's pretty close. Plus or minus 150 volts. So I believe we're there. So the next thing, crystal frequency adjustment. So the next thing we have to do, we'll get rid of that. Connect our frequency counter with a 50 ohm input to the instrument RF connector. Set the signal generator level indicator switches to a higher frequency. Signal generator lever indicator switches to a high frequency, which is within the counter's range, such as 500 megahertz. Oh boy. What if it's not locked? We'll set it for 500. Alright, I'm using this for something else, but that's okay. I'll take the connector off right here. This is calibrated. No, it's not on rubidium or anything like that, but I have calibrated it against a rubidium source, and as long as it's warmed up, there we go. Alright. Now, so let's do it by the book. We're going to set the frequency vernier to calibrated. That's this control right here. Calibrate. Okay. Modulation mode, CW. That's this one here. It's all the way up. Modulation frequency, external. Okay, that's that one. Okay, so far so good. Modulation FM AM minimum, which we have. Alright, let's see, output vernier, fully CW. What it says, output step attenuator to plus 10 dBm, which I have, and then the meter function output. Alright, we are showing 499.9998657. Honestly, I could adjust that. Let's see. Frequency adjust trimmer, figure 5.5 for minimum frequency indication. On the counter, then carefully turn the frequency adjust. I don't know what it means, minimum frequency indication of the counter. I don't know what that is. Now I'm curious. So let's find the M30-1. Luckily I labeled all this stuff, or some of them. So I just got to find it. 34. This is it right here. Frequency. There we go. I marked it actually. Believe it or not. That's this guy. A lot of stuff. So let me play with this a minute. I'll bring you back. Okay, because this signal generator is kind of a hybrid. It's an amalgamation basically of two different generators, which meant the frequency adjust was a little odd, a little out there. It took me a little while to wrap my head around it, because it's been about 8 years since I've worked on this thing, and it's a lot of information. But I found this. It has procedures in there that the Army came up with to adjust this thing. It kind of, but basically it wants me to do 0.001 hertz. Not hertz, but 1,000 hertz. Well, I can do 500, but I don't think my counter will go. I don't think my counter will go as low as 1,000 hertz. I couldn't get it. I don't think this thing will do it. Let me see. It goes to 100 hertz. So let me just put in the center frequency 1 kilohertz. Yeah, everything. Yeah, just the measuring equipment just don't go down that high. So anyway, I'm going to start at 500 kilohertz. At 500 kilohertz on my frequency counter here, it's at 10 seconds sample time, or gate time should I say, and 50 ohms time 1. So everything's set up like it should be, and it's right on. So I am going to call the frequency good. It goes down here through all the steps, and we can go up to 500. See what it does. So we went from 500 kilohertz to 500 megahertz. Let's see what it does. It'll take it about 10 seconds to gather. This is about as accurate as I can get. I may have to go to 1 second. I may have to go. I think it's overranged. Yeah, it overranged. Anyway, 499.99999. That is good enough for me for what I do. All right. So I'm going to move on. I'm just not. I'm not worried about the. Let's see here. We'll do the frequency vernier. That is a little off. I would imagine that would be 0. So it's really, do I want to follow the military way of doing it, which I have no doubt that it's right. But let's try it anyway. Let's see. T1 controls frequency vernier control to 0 kilohertz, which is what I have. Frequency switches to indicate 1 megahertz. So let's put this down 1 megahertz. Modulation mode to FM times 1. Alright. Modulation frequency switch to DC, which I have. Modulation FM AM switch to 10 kilohertz. Now what this does, I have no earthly clue. So if the frequency counter does not indicate between 999.99 and 1020.01, perform B4 through 11 below. So that would be this next page, adjustments. So we got to do B4. Here we go. I'm assuming this is right. Let's try it. So to do B4, we got to do the frequency vernier at 0, which it is. Modulation, I'm sorry, frequency switch is set to 2 megahertz. So, okay, 2 megahertz. Modulation mode switches to FM times 10. So times 10. Modulation frequency, DC. Modulation FM AM slide control to full up position. Alright. Outturn vernier control fully clockwise. Says your modulation note. Modulation board C316-6 contains a size adjust C and a balance adjust D, which are factory. Do not change the settings of these two controls. Okay. A digital, next thing, a digital voltmeter to mod TP figure 1 and ground. Okay, so where the hell is that? Let's see, and it wonderful, it don't tell me what this is, so where is it? Figure 1. Now that's figure 2. Let's go to figure 1. Here we go, mod TP. Mod TP. Let's see if we can find that one. I don't know about you guys, I don't see that. Mod TP. So that's the first card, second card, third card, bottom left. So this would be the first card, second card, third card, bottom one to the left. I'm assuming. 1, 2, 3, 4, the fifth row. So 1, 2, 3, 4, 5. Is that right? Come back here. 1, 2, 3, 4, 5. Is that right? That would be on the third card. So 1, 2, 3, 4, 5. That's what it shows. So let's do that. Find my ground. Alright, let's see. Well, not showing anything on the voltmeter. Doesn't give me the warm fuzzies. Mod TP1 in ground. There's no voltage here. That tells me I'm on the wrong spot. Yeah, that's what I hate about being hybrids. Let me figure this out. Bring it back. Alright. Had to do a little digging there. The mod test point. Let's see here. Get on this right here. To the modulation board C316-2, which is this board. I believe this big board that's on the front here, between the front panel and the main panel. But this board here is C316-2. If you believe it. Anyway, what we're looking for is right here. C316-2 mod TP rear panel. Well, this is the rear panel. It's called the programming, but if you'll look, if you can see it, mod TP right there. So I'm monitoring that point, and I'm at 4.98 volts. That is pretty close. Now, where is all my? See, this is and what I said a while ago, 8 years is not accurate. I actually worked on this when I was working at a different location, which had been longer than 11 years. So we're looking at probably anywhere from 11 to 15 years. Anyway, what are we doing? I forgot now. Just frequency. Oh, that ain't right. Well, we're about to go in the wrong thing, ain't we? Modulation board 316-6 contains a size adjust and a balance adjust, which are factory. Do not change that. Digital voltmeter to mod TP, figure 1 in ground. Adjust modulation board pot A for 5 volts plus or minus 0.01 volt. Well, honestly, that's 0.2 volt, but let's see if we can find it. So the modulation board pot A, alright, I remember that. This has been a long time ago since I've done this stuff. I'm surprised when I figured out. Got a bunch of pots on it, for sure. I'm sorry, this is the modulation board. It's 2 boards. This is the front panel board. It's got all the various things in it. So we got 1, 2, 3, 4, 5, 6, 7, 8 very trim pots. So yeah, this is very plain, isn't it? It says here 5. I don't know. I don't know what these are. I remember having that problem before. So let's mark this page. We can get back to it. Alright, let's go back here. I remember there being some differences. I remember there were some oddities about this. Oh Lord, bring back memories. Here we go. Balance and size. Those two are the ones you're not supposed to adjust. R47 and R42. Yeah, instead of boring you over this, let me figure it out. Okay. Now that I got my hat bearer out of my derriere, pot A is the one we need to adjust for 5 volts. Pot A, this is not the modulation board. Wrong again. This is the mod board. And pot A is right there, which makes sense. So let's see if we can get exactly 5 volts out of this bad boy. Actually, it's at the end of its range. At the end of its range. Imagine that. Isn't that something? That, what I was telling you folks. Turn to the minimum side. I have have no clue. It doesn't tell you which one it is. It says R42, R47, R42 right here. 5 volt adjust A. That's it right here. Alright, let's see what it does. We are on FM times 10, DC maxed out on 10. Let's see what's going on there. Oh Lord, let's see here. Here's the adjustment. Plus 18 volts through voltage drop in resistor. 400 hertz, 1000, 400, 1000. Well, see, that's weird because this S1 says DC. Well, that makes a lot of sense, doesn't it? Don't get that at all. What is it doing here? This pot here, it can't just go to DC. Oh Lord. Back in a minute. Well, as they say, the plot thickens. Who said it? I don't remember. Probably Sherlock Holmes. Who knew? But anyway, you have plus 18 volts coming in here to the test point A, which is a 5 volt adjustment. Goes through a 5.11K resistor, goes through the 5 volt adjust control A, R42, and goes to ground through R41, which is 2.74K. Yeah. Anyway, center arm comes up, which I had to, not easy to do, but I had to figure this out, which this drawing kind of crazy. These people must have been from Sweden. Anyway, in the DC position, the switch takes this 5 volt right here into the DC section, connects to here, comes down to R44 10,000 ohm, which is the AM FM modulation, which just happens to be, you can see it, this control. So anyway, taking that control, where is the devil going on here? Oh my God, I had it on Zoom. How long did I have it on Zoom, y'all? Golly, I must have hit Zoom. I'm sorry. This is R44 right here. Okay, so that would be this guy. Alright, wherever the heck it is, right there. Here is a little op amp, IC3A, it's an MC1450. The output of that comes down, comes over to R49, a 1K, comes out to the rear panel, mod TP. So anyway, this control is maxed out. It's at 2.75 volts right here when it's maxed out. Alright, so with that in mind, this becomes a parallel circuit, series parallel circuit. Now I got to sit down and do the math, but anyway, this control is the mod control maxed out, which only gives me 4.99 volts maximum here. I don't know what the maximum you can get out of that is, but I wouldn't think that this thing would be maxed out. What is that? Oh, that's what that is. I don't know. I'm going to do the math and just see what this is. see what I can expect. Maybe the op amp's bad, I don't know. Bring you back if I even find anything. Okay. What I just run into reminds me of this YouTuber called Watch West Work. He's a mechanic, auto mechanic that works on various things, and the way he talks about things, and he's just like, well, here's one of those things. Well, I'm going to be that way too. One of these things that maybe I'm looking for problems. I don't really want to be working on this like this, but anyway, back to this voltage network here. There's 18 volts through this 5.11K, through this 1K adjustment pot, 2700 ohm resistor, goes in through a 10K. So, and I was measuring 2.76 volts right here. So I drew the equivalent circuit of that. Here's the circuit right here. 18 volts, the 5.11K, the 1K control, 2700 ohm to ground. I forgot to put my ground symbol. But it also comes off this control to a 10K control. Anyway, it's marked as resistor because I don't care what's past it. Anyway, simplify it down to this. And then simplified it down again to this. In other words, these two resistors added up to this. Then I simplified that down to this. Now when I got that, I did little Ohm's law, which I added basically this 5.11K up to this combined resistance of these two, which figured up 2700 ohms, basically resistance. Gave me about 2300 or 2.3 milliamps. So I take that milliamps and calculate it, use that to calculate what my voltage would be across these two resistors, and it comes up 6.26 volts, not 2.75. So there we are. The input to that op amp should be a high resistance. I wouldn't think that would affect anything. So what do we have here? Do I have maybe some bad resistors here? Or am I just, my thinking is bad? What do you think? While y'all thinking about it, I'm going to do what I don't want to do and open this thing up and start measuring resistance. Got to be something wrong. That control shouldn't be maxed out to give 5 volts. So I'll bring you back. Well, that was fun. Getting this thing off. There's the board in question right there. Am I back in telephoto again? So, I'm probably way wrong, and I know us is chasing a red herring. This is A right here. And if I remember right, 18 volts comes into one side of A, goes through A, comes out to ground. Center tap of this guy goes down into the high side of this guy. The low side is ground, and then the middle goes over to IC3, which is probably this guy here, I would guess, but it could be any one of these. I have no idea. So now I've got to do some more checking. So matter of fact, let me get my light over here so we can look at this together, as they say. Supposed to be a 5K resistor in here somewhere. That looks like the two of them right there. That doesn't look like 5K. This doesn't look like 5K. Beats me. I'll come back. Alrighty. Yeah, it was a lot of fun. Let's recap real quick. This is over here where somebody can see it. This is the circuit right here. Remember, I had 2.76 volts right there. Well, this thing turned all the way up, and I was able to measure it on this control, on this switch right here. Anyway, 18 volts comes in through R43, which says here 5.11K through this 1K through this 2740 ohm resistor. Okay, R43. Let's see, R43. Well, let's see. R43, which is what? 5.11K? No, it's not. This is a 1, 2, 1, and in other words, brown, red, brown, red. This is a 5-banded resistor. Well, that 1, 2, 1, 2 turns into be a 12.1K resistor. Was not expecting that. This is another mod. Who knows if it was done at the factory for the military, for this modification, or what. Needless to say, I can barely get my 5K, my 5 volts out of this thing. Now the second resistor is marked, let's see, it's actually marked 2000. It has a red, black, black, brown. That means there's 3 digits which indicates value. So that would be a red is a 2, the 2 blacks are the 2 more zeros, so that'd be 2, 0, 0, and then the brown denotes another 0, so-called multiplier. So that is a 2000 ohm resistor, which measured about 1700. But remember, this is a series parallel circuit, so that's what's making my resistance. This 12K is interacting through this 1K through that 10K control on the front. I have a freaking clue. Much as I don't want to do it, I'm going to pull this board off and I'm going to see if this has been a mod or somebody been in here, because somebody's been in here before me. So I don't know. I'm going to open it up, see if somebody may have went in here and changed it with some other resistor, but I highly doubt it. But oh well, I like punishment. I'll come back. But matter of fact, hang on just a minute. Let's just hang on here. Right there. This has not been tampered with. So that has got to be factory. So yeah, I figured it's going to be some kind of BS like that. I think we're just barking at the wrong tree. Battery's going dead and all that, so bring it back. All right. What I've done is I'm really OCD. I don't like it when things don't do what the manual says. I don't like it when things are at the end of their range. Just never have. But basically what I've done is, in this circuit right here, this was a 12.1K instead of a 5.11. I don't know why. So anyway, this was a 2000 ohm, this was a 1000 ohm, and this was a 12. Everything else was normal. So what I did is, remember, this thing here was maxed out and it was only giving me 4.99 volts. I would like it to be able to go above that and below that. I don't know about y'all. I'm just being OCD. So basically, what I've decided to do, this is not the problem that I'm looking for, but it is just some little thing that bothers me. So basically what I've done is, I've checked the circuit out. I took this whole front assembly out, as you can probably see. Not that hard, it's a pain in the butt a little bit, but not that bad. But this is the control, these are the 2 resistors, this is the IC, and the output. There's your plus 18 right here, your minus 18, your modulation test point right here, your ground, another ground for my power supply. And basically I'm just using that dude right there to give myself plus and minus 18 volts. doing that, I was able to go in here and measure all this stuff and make sure everything was right, which it was. But I wanted this control to be about mid-range to give me 5 volts. So basically what I did, to do that I needed more voltage, right? So to get more voltage I needed to change the value of this resistor. So I just went in there with that 12 that was in there and started jumping resistors in there till I could get about what I wanted, which turned out a 47K in parallel with this 12K right here gave me the proper voltage. I had to touch it just a little bit. So calculated that, come up to a 10K resistor. So I substituted the 12K with a 10K resistor, and now I have exactly 5 volts. And if you look, I can drop it, goes up to 6.03 and 4.25. Now I can put it anywhere I want it. So with all that being said, I'm going to put it all back together and continue on. Okay, got the modulation board back in, and I remembered that the vernier control right there for the RF output, remember it was dirty or noisy, which resides right here. So I'm going to pull this thing out. I've already taken the knob off. I'm going to take these two leads here off, or these 3 wires, and pull it out. It looks like it'll come apart. I'm going to clean it real good, and hopefully it don't destroy it, and put it back in before I put this front panel back in. So we get done, let's when I get through with all that, get it all back together, then we'll go back to that modulation test point again and see if we can get that to adjust, and we might call that a video. So anyway, bring back. Alright, well, for whatever it's worth, guys, I'm going to bring you along for this here. I've got the vernier control out, vernier, fine tune, whatever the hell you want to call it. All you English grammar police out there, feel free to jump in. Thought I had a good screwdriver somewhere. Here we are. Sorry about that. Thought I had my crap together. Anyway, here it is. It is an Allen Bradley mod pot. Okay. Whatever you say. Anyway, it looks like it comes apart. Can't say I've ever had one of these apart. Which is good. Some of these other controls that are always dirty and needs cleaning, completely sealed, you can't get to. You just have to replace them or drill a hole in them and hope you don't tear up nothing. Whatever, you know. Whatever floats your skirt. Can't say I've ever taken one of these apart. But no fear, I have another one, another generator just like this for parts. So if I destroy this, okay, well there's a cap, and then there's this little piece of metal, and then here's the center section. That didn't work too good. I've never had one of these apart. So, looks like I'm just going to spray the shit out of the controls. I mean, the control cleaner. Put it back together. Okay, well, don't know all I can do there. He's gonna make me eat lunch, isn't it? Probably out of frame. Yeah, ain't that special. Let's unzoom this thing so you can watch a man suffer. Let's see. Alan Bradley. This is the top. I guess it matters. This thing within close enough. I'll get it back together. Anyway, that's all. Get it all back together. Let's see if this thing will work. Alright, finally got it back together. A little harder to put back together than it was to take apart, I swear. Anyway, we got everything done. I got the little slight modification done in there to the modulation board, pot A, which is the modulation adjust, which is that little pot right down in there. So we're ready to power it back up. Hopefully it don't go boom. Hasn't locked yet. I don't need it to lock. Anyway, I'm at 4.94, 4.93. So I'm just going to set you down there. I'm going to adjust the control. I should get my 5 volts now. See, I can go all the way up to 6 volts. So I've got plenty of range now, which is what I like to see. Now I don't have a 5.5 digit multimeter. I wish I did. Anyway, that is done. I have plenty of adjustment range now. Went in, cleaned that control. That's the next thing. We'll see if that helped the output level. I turned off my my spectrum analyzer. Didn't need this big jet engine sounding new to be running all this time. So my battery's about to run out on my video recorder. So let's do 2 megahertz center frequency, and I'm going to do a frequency span of 2 megahertz. I'm sorry, yeah, 2 megahertz. Center frequency 2 megahertz. Where is my signal? Because it's not still not. See, the original problem is back. Yep, there it goes. So here's 2 megahertz. Span this thing out to 5 megahertz. Oh, good reason why. Didn't hook the output up. Wonder why I wasn't getting no output. What's going on here? I'm like, what? Nobody in the world. Why are you fighting me? 11:30 seconds. Working on 5:30. On 5/16. Trying to mess up thing, act like a rank amateur here. Alright, now, where was I? Let's see. Yeah. Now, I could adjust it now. The over unleveled LED doesn't flash. I'm going to set it for 0. I'm going to set it for minus 20 dB. Nice, clean looking on waveform. We're going to adjust the vernier control. Look how smooth. Boy. Well, if I didn't fix anything else, I fixed that. Also, I got the smoothness of the vernier control. We'll have trouble with that one. And I've got the mod adjust control, which is the control A on the mod board. Got it corrected where we can get our plus or minus 5 volts now. So I guess the next thing, I'll have to look at the manual and look at the schematic, study this thing a little bit more, but that was quite an interesting little foray right there. I had notes on when I did this before, and apparently it's been over anywhere from, I'm going to say 12 to 15 years ago when I last went through this thing. But I made notes on all my, and I looked at all that what's different. So, but anyway, now that I've got that mod control where I can go below and above the range, I can move on to the next. And that's why I like to do alignments, because, you know, look for why the alignment don't work, then you'll find a problem. And that's how I'm approaching it with this one here. Now the problem is this thing is a mismatch of the, we'll just say the civilian version signal generator versus the military version. Now remember, I took the two and made one, which makes the schematic a little weird and the circuits a little weird. I have to remember, I have to sit down and map what does what and where and why. It's been a long time. When we made it this far, so I guess I don't know where I'll go from here. I'm fixing to have to. It's still, like I said, it's Memorial Day 2022, and it's almost 2 o'clock in the afternoon, which means I got to go to the store and get stuff, and so I can cook if there's anything left. So anyway, thanks for joining, and we'll get in something a little deeper next time. All right, peace, y'all.